I'm really proud to say we're 25 years in business this month, so feel really happy to be here and share experiences with you today. So thanks very much, Kevin, for that warm introduction. What I'm going to talk today is about upskilling the trades. We need good details, we need good products, but we actually need to kind of make it happen on site, and we're going to focus on one very tricky aspect of high performance buildings, and that's airtightness. You can buy windows, you can buy ventilation ducts, you can buy rolls of insulation, you can't buy airtightness. Airtightness comes from these two things, okay? And it needs like real passion and dedication. And where we're working on very high performance buildings, and we're working really at the thin end of the wedge. Like we do senior hurling. If this was Croke Park, I'd be saying senior hurling. I don't know what the analogy is for rugby, but of the 5 pillars of passive house and high performance buildings that you see there, I really want to focus in on airtightness. Now you can't teach airtightness with PowerPoint, right? I couldn't actually upskill everybody in this room here to do good airtightness in this room using slides. That just wouldn't be possible. And this photograph was taken from our own house that we built in Wicklow down in 2004. The guy with the blue waistcoat is a Fenstermeister, and that's German for window master, okay? And unfortunately, he's not Irish, he's from Austria, and he's training up my brother-in-law, Patrick, in the white hat there, you know? And that photograph is 14 years old, but you can see in that moment, he's showing him the tape, the airtight tape, and we had never seen that before. And this wasn't duct tape, this was like really good tape. How do you use it? Where do you put it? And so that was kind of the start of our journey on that. Now, we've talked a lot today about airtightness and the benefits of high-performance homes. And airtightness brings a lot of benefits. It obviously improves comfort, but it also, when we need to talk about vapor control, okay? We have a serious problem with our existing building stock with mold, with interstitial condensation, with all sorts of stuff going on inside in the envelope. And so airtightness is not just about comfort and about drafts, it's also about reducing the risk of interstitial condensation and all sorts of problems in the building envelope. So we're actually doing a lot of benefits when we improve the airtightness and the vapor tightness of a building. So we have this scale here going from 7 to 0. So right now you can actually build a building, achieve an air permeability of 7 and not go to jail, believe it or not, okay? For NZEB, the new standard, the upper limit is going to be 5. If you build to a permeability of 3 or less, you need mechanical ventilation. The EnerFit standard, which is the passive house standard, now the numbers are slightly different. It's air changes per hour rather than permeability, and we can have a boxing match in the car park about that if you want, but it's pretty much equal. So basically, if you're north of 3, you don't really need any specialist expertise. You can basically mullock along and get a few tapes and do this, that, and the other. We're really, if you want to get less than 3, we reckon you have to have an airtightness champion. So this is somebody on site who, it's on their dashboard, they're going to the building site and they're concerned about this and they're working through all the details and so forth, okay? This is Cooper, one of our pets at home, and Cooper's an airtightness installer. He's got his high-vis jacket, he's got his special Sega tape and all that, and like on a new build, even Cooper could get 3 or less. I'm not kidding, right? He actually does this for a living. So basically, if we want to do better than 3, we want to have good air quality following on from Shane's presentation, we want to have good mechanical ventilation, we're going to have to do better than Cooper, okay? And I'm going to show you now how we can do that. So this is a project we're doing right now with Dublin City Council. It's the best fun I've had for lots of years. So this is a 2-into-1 conversion, 2 tiny bed sets being converted into one bedroom apartment. So we're converting these 22 bed sets into 11 apartments. And we needed to kind of do a sample test because we're looking for a really, really good level of air tightness here, less than 1. So just remember that scale of 7 to 1. So we're looking for less than 1. Now I actually didn't tell the contractor we can go with 1. I said, look, we're aiming for 0.6 because I wanted to kind of skirt over the retrofit standard and go straight for the new build passive house standard. So I didn't say to the contractor, if he's here, sorry, that 1 is okay. I said to him, the benchmark is 0.6. So we want to do a sample apartment, and these things are tiny. So to get that level of air tightness on a small unit is like really, really difficult. Now, just beside and next door to this apartment block, they had done a deep retrofit previously. They got an air change of 5 upstairs and an air change of 3 down below. So what we were looking for here was like 4 times tighter. And it was the same construction crew, the same City Department of Architects in Dublin City Council. So they were really saying, gee, can we really pull this off? How is this possible? And so we had lots of fun, and I have to keep you in suspenders until we tell you whether we made it or not. So basically we had this idea of running this holistic training program, and it's not just on air tightness, but it's on thermal bridging and windows and all that cool stuff, you know. So I wanted to be on absolutely everything. And you've got to teach people theory, like not just how to do it, but why to do it. What happens if there's a tear in the envelope? What happens in terms of vapor, moisture, movement, and indoor air quality and all that? So, but it can't only be theory. So we said, right, we'll do 50-50 theory and practical. And we also got pro demos. So these are the professionals who do this work day in, day out. We got them to come in and do a pro demo. We're using the real construction details for that actual project. So again, it's not arbitrary, and we're doing it on the site. That was the most exciting thing about this project. So we're not bringing the contractors off to a hotel. We're actually doing the training in the canteen, in the building site canteen. So there was very little time spent away from site. And then we could sync it with the construction program. So basically, and we had to vary it a bit. We had this idea we'll do first Wednesday every month, but we had to change that because the construction program was changing. And then the great thing about Airtightness is we can verify through testing. There's a thing called a blower door test. And they all arrived for that blower door test, about 25 of them. And it was really it was like everybody was super nervous about it. And I had an idea already it was going to be okay, but I was kind of coming onto the site really worried looking. So this is all part of this research project that we're doing called Fit to NZEB. It's an international research project to do it to retrofitting. So I'd love you to check out that website so you can see that project and what we're doing there. So here we are in the canteen, and step 1 is to cover the theory. So why is airtightness important? What are the benefits? What's the physics involved in airtightness? The different vapor permeabilities of materials, the longevity of airtightness tapes and so forth. And then we did, step 2 is basically, this is kind of, you know, learning how to ride a bike with the kind of stabilizers on the side. Okay, we didn't want to let them loose on the site yet. So we make up these models. I have these in my Jeep, and we stuffed them into the Jeep. It's like super Jenga. You can see these kind of 3-dimensional models. So they have penetrations, air pipes, you know, cable penetrations, and they have kind of mock window frames as well. And it's really a lot of fun. And you can see them here struggling with the tapes and the membranes. And I'm telling you, an hour of this, they're set for life. I mean, this is like, then they can really make really good air tightness for the rest of their careers. And they realize this stuff is easy. It's just about being neat and tidy. And then we have these pro demos, and I'm really grateful to the contractors who helped us out on that. So one of the pro demos was an external wall insulation. And, you know, we all hear and talk about EWI, but I mean, how many have actually seen it and the techniques and so forth? I see one person in the audience here is in that photograph. And so you can see there the pro demos were lots of fun. Also in terms of airtightness, what kind of membranes? There's new products coming out now. There's liquid applied membranes, which we use in the US a lot, but they're quite new here to Ireland. This is basically a paint-on membrane, which is super convenient for a floor-to-wall junction in an old building where you don't have to get down on your knees. You can actually spray it on if you want, or you can paint it on. And another one of our pro demos is over here, that man with the very distinguished looking mop of white hair there. And so, you know, the mechanical ventilation. So we're dealing with the 5 pillars: the insulation, the airtightness, the windows, thermal bridging, and the mechanical ventilation system, all on site. Nobody's spending time away from work, and they're learning it the theory and they're learning it in the practice. So then basically people got to get their hands dirty. So we're literally doing this. So the students are actually now applying the airtightness, and like this is like a really difficult project. Okay, it's not occupied, so it's much more challenging than what Owen is doing. You know, this is basically where people are not. This building was decanted, so it's considerably easier starting with a kind of a fresh slate. But again, you see that you can get a sense of the experience here. So everybody had a really good time, and they were all totally buzzed up about that. And a lot of people learn, and it's really like origami. Like most men are useless at wrapping Christmas presents, at least in my house, and. So if you, like all of these guys are going to have the best Christmas wrap presents like ever. The wives are just going to be like pumped next Christmas. They're going to be wondering, like, who's been coaching you on all this kind of wrapping up. What's that? They won't be able to open them, exactly. If they use good airtight tape, they won't be able to. So, like, this is what we're starting with. It's basically a kind of glorified cave, you know, so it's super difficult. How do you deal with all these materials, different surfaces, and all sorts of difficult things? So, the roof to party wall connection, this is the challenge, this is the detail, and this is the application. Now, look at that quality of workmanship. I mean, it's, when I walk, you can tell basically within probably 5 seconds the number you're going to get on that 1 to 7 scale, because it's all to do with attitude, tidiness, and application. And the membranes and everything on that ceiling was like a Bowron. You know, if it's taut like a Bowron, it's going to be a very low number on the scale. And it's just beautifully working. I really have to compliment everybody involved in that. And then the floor to wall detail, you know, these are old snotty floors with bumps and hills and hollows and all sorts of difficult stuff. And that's where we started to use this paint on Airtightness, liquid applied membrane it's called. And apparently it's quicker and it's cheaper than some of the tapes, because that's an interesting one specifically for that junction, something you might consider. And then the airtightness for the walls is just plaster, and we can get a really good airtightness with sand and cement plaster. So we did the test result, and we've got the crew there, the contractor, the architect, and myself, and this was the result. So remember, I told him we were aiming for 0.6. I didn't mention the 1. Like, 1 would have been okay, but I said, no, we're going for new build passive house. And you can see the very bottom line number there, 0.58. And believe me, that's a tough number to get on this scale of 0 to 7. And we'll be doing more tests. This was the very early preliminary test to see how we're getting on. And there already are penetrations in the envelope now. So we don't expect any disimprovement of that, but we'll have to keep an eye on that to make sure that it doesn't get worse. So effectively, in this Arbor Hill project with Dublin City Council and with Westside Contractors, we've got a 0.58 air changes per hour. We also did a super project with Dún Laoghaire right down. See, Andre Dargan, County Architect, is here. And Andre, I think, presented this project maybe last year. And they've applied your methodology of volumetrics. Basically, they put an extra floor on top. So it was a 2-story, and then they put an extra floor on the top exactly for the rationale that you've explained there in your presentation. And they got a terrific result there of 0.76 air changes per hour. So fantastic result. We do a lot of work in the States. So when the crash came, basically, we ran out of work here. And we set up a company in the United States, in New York, and we have a consulting and training company over there, and we're very active in Passive House right across North America. But this was the first Passive House project we did in the US. It's the first certified one in New York, and you can see that blue building there in the middle. So that's a retrofitted, you know, it's a 200-year-old Brooklyn brownstone retrofit. And we got a 0.38 on that project. It was quite interesting, actually. The architect for that project, she flew to Ireland for training, right? There's business here, right? So she flew to Ireland for training, and up to that point, they were using this foam, you know, this shitty air foam that you put in between the frames and the wall for airtightness. And we took out this roll of tape, and she said, "What's that?" And I said, "Well, it's airtight tape. You know, you got to use that for airtightness." And she went back home, and she went directly from JFK to the job site with this roll of tape, and she shot the guy who was spraying in the foam, put him in the dumpster, and no, she didn't really. And and then they started applying this tape, and look at this brilliant result. And it was also kind of a funny story. There was a lady playing the violin next door every day at 3 o'clock, and she really was very, very bad at it. So at 3 o'clock every day, the contractors would say, the old lady's killing the cat again. And finally, when they were getting the building tighter and tighter and tighter, they were saying, well, maybe she's passed away, or maybe she's not playing anymore. Basically, the noise pollution coming from next door wasn't so bad anymore. Project I'm really proud of is for a small company. We're based in Rathnew. We were the energy consultants on the tallest passive house building in the world. So this is in Manhattan, 26-story. It's built on an island in the East River, Roosevelt Island. And what about that for a result? So this is at 26 stories. We got a result of 0.14 on that. For the geeks in the room, the air permeability was 0.58. So even for the air permeability number, we're like it's just off the Richter scale. And I was asking the contractor, how do you feel about that? Is this a good result? And he said to me, son, he says, this is as tight as a camel's ass in a sandstorm. And it's kind of an analogy I never forgot, right? You can't get that image out of your mind. But what I want you to know is we actually, our little company from Wicklow trained the contractors. We took a sample floor. So if you're doing 27 stories, you can't wait until the very end to see if you've got there because it's too late. They're already putting in the carpet on the first floor when they're still fitting out the 27th floor. So we did a sample floor. That's one of my colleagues in the lower right-hand picture there, Kevin Brennan. And we basically isolated the 6th floor, and we basically developed a system. It took a few days, and then we could repeat it throughout. And I mean, that's probably the tightest tall building in the world, actually. So that's a really, really sort of good result. Okay, so as several people have been saying today, we need to go beyond pilots. I actually think we're ready. I think we've done enough. Well, we need to do more, obviously, but I think we're actually getting beyond the pilot phase now. And I think it's time to make this mainstream. Okay, a very exciting project we're doing with WWETB, Waterford and Wexford Education Training Board. This is a super fun project that I'm working on at the moment. They're actually developing a national training program for contractors for NZEB. It's the most, again, like, gee, we're just having a blast with all the work we're doing at the moment. But what's really interesting about this is it's specific training programs for foremen, for bricklayers, for plasterers, electricians. And what I didn't expect when we were writing the skill specification is, you know, the plasterer in Ireland is going to be the airtightness guru because we like to use sand and cement. And the plumber is going to be the ventilation person. And the block layer is going to be the thermal bridge expert. So all these guys who are just out just doing their job now, in the future, they're actually going to have a very, very serious role in this. So do keep an eye out for that. That's going to launch in September of this year. And again, the ETBs around the country do fantastic work. They don't often get recognised for it. And just to bear that in mind. A bit of a plug for an event tomorrow week at DIT. We're having a rapid housing conference. A lot of thematic. Basically, it will be a lot of information on NZEB. So it's basically how to build NZEB at speed. I would love you to come to that conference. We've got a really, really good panel of speakers as well. And if you're interested to know more about the Cornell Tower in Manhattan, I'll be speaking about that for next week. So do keep that date free for your diary next week, next Friday. That's it. Thanks.